Hi guys, welcome to TechoGenius Academy. We are industry-led training providers for those who wants to build their career in data science, analysis, IoT, device driver, embedded Linux and many more. Please do like, share and subscribe to our channel.
Hello guys, welcome to the TechoGenius Academy. Hope you all guys are absolutely fine. So yes, we are back with another session of Linux device tree. Actually, from last few weeks, like I was getting comments like we were getting difficulties in connecting that hardware and all. Means we wrote the driver and we were getting the difficulty like how it will be connected to the low level hardware and how we can write to that registers and all. So basically like people are very well like whatever the difficulties you were getting, they know about that user level driver, user level mode driver and the client driver, but further when it jumped to that register level, that low level hardware, they were getting difficulty. So I just come up with that idea that probably we will upload some session and step by step we will go further as I was explaining some ISKC driver also. So if you can see here that embedded ISKC driver, Linux USB driver, but people are like you guys are requesting for behind the concept, behind the scene stuff, like what is happening in the back side, like how it will be connected, the driver, how it will be connected to that low level hardware. So today we will discuss about that, and probably like I will demonstrate one driver, like I will demonstrate one UART driver, how it will be connected to that Linux device tree. Yeah, so without wasting any time, let's get started. And what I want from you guys, like if you just go through these sessions and all, like those who are coming first time, so you'll like these sessions and all. So I just want you guys to subscribe to this channel and please share it to your friends, so everybody will get benefited from this huge knowledge. So yeah, so we will jump to that our session and all. So what actually my recommendation for Linux device tree, you can go for Linux device tree for dummies. Yeah, so I just want you to go through this. This is having a very good stuff and all. So you will get as much as knowledge from here about the device tree, like and what is actually device tree and what are the components they are using. Actually the device tree is a tree data structure with the nodes that describe the physical device in the system, as it is explained here, but we will jump into the core thing also, and you will get the information about that, what are the status, compatible string, and how it will be connected. So I just want you guys to go through this. So I also got like a few information, I just copied from here, so I just combined it in that video. So yeah, this is the one stuff, and this PDF is the is for those who will start with this driver stuff and all, and further going in the last, like I will tell you like from where you have to go, where you will get the deep dive knowledge. Like you want to, if you want to explore more, if you want to dive into this interrupts, like how it will be connected and how it will be used, if you want to know about the DMA stuff, so probably like I will tell you in the last, so like in this session only. So yeah. So first of all, we will explain, like we will just get a few of the information about the device tree. So as I have already explained, device trees are, it's just a data structure which is having multiple nodes, which will help you, or it will describe you the physical device in the system. Okay, so it's probably like you will have your hardware, like if you'll talk about the communication protocol, like you have the ICSC, you will have SPI, you will have UART, USB, like different drivers you will have. So that will not be in your particular board. You will have the separate hardware. So your device, whatever the hardware you are using, board you are using, a BeagleBone, STM, TI boards and all, and the slaves, you can say ADCs, RTCs, EEPROM and all. So that will be your slaves. So how it will be connected? So on ARM, basically the device tree is the main thing which will help you to bind with your with your drivers, with your this hardware, sorry, with your hardware and all. So all device sources, as you can see, it will be located in arc arm boot DTS file. So if you don't know, I'll just go to the terminal and okay, cd comps BOS Linux. Yeah. So cd arc arm / boot DTS. So all the DTS files you'll get it here. If you want to know about the BeagleBone Black, the common DDSA file. So this is the common DDSA file, and if you want to know about this, yeah. So this is the DTS file where we will change the configurations and all. So yeah. So I will explain today some of the good stuffs related to UART, and probably we will jump into the SPI also if we got enough time. Okay, so yeah. So each module in that device tree is defined by a node. So module means like you have ICSC, you have SPI, you have UART. So there are different modules in the device tree. We can say it is a node, and all its properties are defined under that node. So there'll be a big node over there, root node you can say. Under that there'll be a parent node, and suppose you have a ICSC controller. Okay, so with the one board you have multiple devices connected to your board, multiple ICSC devices connected to your board. So it's not like that you will remove one of the node and for that particular driver, and you will enter the other node with different addresses, whatever the address of that hardware it is. So with that, like one parent node will be there, and there will be a multiple child nodes. So you will have the different hardwares with different addresses, with the different interrupts. If you want to use DMA also, whatever the properties you are using over there is, for that you have that different child nodes. So under that you have that depending on the driver also. Okay, so under the root of the device tree, one typically finds following most common top levels. There are the CPUs, memories, chosen, aliases and all. So what I will go, okay, so yeah, so I have this like one of the DTS file, and as you can see here, this is the root node, as you can see, and there'll be a aliases. So there are different drivers are there. There'll be Ethernet driver, there'll be a serial driver and all. You can just find out here also. Like, let me just check VIAM33X clock DDSA. Yeah, these are the clocks. .ts. Yeah, so this is the actual device tree source for AM33XX SoC. So you have that aliases, you have that CPU, this is the root node, and in aliases, like you have the different ISKC, because you have multiple UART, you will have multiple USB in that board. These are the facilities like SPI 0, SPI 1. So how many interfaces you will have in that particular SoC. So right now we have we are using BeagleBone Black. So we have I2C 0, I2C 1, I2C 2. So we have different interfaces attached to that. So this is the thing. And yeah, so what is actually CPUs? It's each somewhat describing each CPU in the system. Okay, so whatever the information you will get it here, it's like whatever the CPU it is using. So BeagleBone Black will this AM33XX will have will have that SoC actually, ARM Cortex A8. Okay, so what is the device type, what is the reg is actually you can say the addresses. It depends what kind of hardware it is attached to. As now we are we are talking about the BeagleBone Black, we are talking about the SoC for AM33XS, and if we'll talk about the hardware, the different hardware, if it is ISKC, then in this reg your ISKC address will be mentioned. If you can say if it's SPI, in this reg area your chip select number will be present. Okay, so if it will be memory map, the memory mapping, then memory map address will be mentioned over there. So it depends like of what kind of hardware you are using. Okay, so going further, there'll be a memory which defines the location and the size of the RAM. Okay, so as you will have the memory stuff also here, let me just check. Like you have that memory stuff also here, and as it's just not mentioned here, like I was just looking into that only, they have not mentioned that. Let me go to that. Yeah, as you can see here, this is one of that thing, and whatever the addresses reg is there, what is the device type, the device type is the memory and all. So you will have that information, that size of the RAM and the device location. Chosen is like defines the parameter chosen or defined by the system firmware at the boot time. In practice, one of its usage is to pass the kernel command line. Okay, so aliases, as I have already explained you, it's a shortcut to that certain nodes. One or more nodes defining the buses in that SoC, like whatever the different buses are there. There's the ISKC bus, there will be a USB bus, there will be a Ethernet bus, there will be a SPI bus. So it depends on that what are the different buses attached to that particular SoC, and one or more nodes defining on onboard devices, whatever the onboard devices are there. Okay, so onboard devices like UART is there now. So there is nothing like we need to use some extra hardware over there. So the best part in UART, like what I like the most, you can just do the loop back, and you can just if you want to try, the best thing is you can just open another terminal, and from there you can access your UART, which is actually attached to that to the driver. So you can just send the data from the another terminal, and just see like if you're getting those data in your console, in your original console where you attach your driver. So that is the best part, I got. It's best method for practicing your stuff also. So the back is you can use it in any of the driver. It's not like that. You can use in the ISKC also, you can use in the SPI also. It's just like you just have to short the stuff, the TX and RX. So in the SPI you just have to short MISO and MOSI just to get the data. Okay, further you can first try to short that pins. Further, if you have that hardware, just connect your MISO and MOSI line and check what the data is correct or not, but don't go for directly to that hardware and all. So it's just like a step to step understanding. Okay, so yeah, so we were discussing about that Linux device tree and the structure. So in that as we were going further, so you will have the multiple nodes. As you can see, there are multiple nodes present over here. There'll be UART 2. As you can see here, there'll be UART 3, there'll be a compatible string, there'll be a hardware mode, there'll be a clock frequency, there'll be a rec, there'll be interrupt, and there'll be status. So different members of the particular node is present over here, and this is the address of that a particular UART driver, and this you can get it in that BeagleBone TRM. Okay, so whatever the SoC you are using. So one by one we will just have the information, like what is actually the functionality of that members. So we will go to that presentation. Yeah, compatible string. So the compatible string used to bind a device with the driver. So it's just a simple definition, but how it will be connected. Now I will just go to the driver. So this is the one of the driver UART driver. So which like I have already got that kernel object file, and probably like I will demonstrate also. So as you can see here, there is a platform driver structure, and there'll be a match table also. Okay, and this is the populate of match table, and this is the compatible string, as you can see here. Now what will happen when your device will be probe, like when you will insert the module, it will just from the device tree, it will just check this compatible string. If you are inserting the module and in the Linux device tree in the DTB file, so what you have to do when you are working on some drivers and all, you have to modify your DTS file. So as probably like this is the AM335 bone black DTSI, this file you have to modify, and after that you have to run this, you have to do make, which will give you the device tree blob. So DTB file, so that you need to put it into the your into your board and all. You just need to mount it. Okay, then only when you will insert, when you will run the driver, it will check in the Linux the device tree source that a particular compatible string is present over there. Like, is it inserted? It is probed. If it is probed, then it will match those string. If it is matched, then probably your device will be initiated. Like, if it will just check this compatible string, so your device will be probed. Okay, so this is how the funda of this compatible string. Like, if you want to probe your device, your deep from the, like, when you will insert your module, it will just check that compatible string in the Linux device tree, and if it's there, then it is just probe your driver. Okay, so yeah. So the next thing, the reg, as I already explained you, it defines the address for that particular node or that particular device, that whatever the different devices as you are using. Address cells is also there. It indicates how many cells are needed to form the base address part in the reg property. So there'll be multiple cells present over there, and from there, like, you need to get it a base address which will help you to connect to that particular hardware. So as you can see here also, they'll be there now. Some of the drivers are using that address cells, some are not using. See, address cells are there. There'll be a size cell is also there. So it's just like the information about your devices, like the size of the cell size part of that reg property and all. So if you are if you're talking about mmap, if you're talking about ISKC, if you're talking about SPI and all, so reg property will have this stuff. So there'll be a interrupt also, like as you can see here, there'll be an interrupt also. Interrupt property, as the meaning of this is, like, if your device is capable of handling interrupts, then if you want to use interrupt, you can put it into your device driver and all. Okay, so it indicates the pin it indicates interrupt number 2, like means whatever the device you are using, you have the particular number with that. So whatever the number you want to use, you want to get it from the data sheet or something like that, or whatever the hardware information you will get it with that device and all, you can use that. Okay, so there'll be a pin control also, pin CTL CTRL subsystem, which will allow you to manage pin muxing. Have you wondered that, like, if you are using the particular hardware, you are using some pins like serial clock, your serial data pin, your MISO, your MOSI, how it will be sent to that particular hardware. Have you imagined that? So the thing is, you have to mention those pins in the device driver, in that device tree. So as you can see here, this is the information of that UART. So it'll be like, for RX it will be pull up, for TX it will be pull down, this pin CTL pins. So okay, so if you can see here, pin CTRL -0, so this is like -n. So whatever the value you want to mention, 0, 1, there are so these property allow it to give the list of pin control configuration needed for a certain state of the device. Okay, so there will be a pin control names also, which is default. The meaning of the default is whatever the default pins you are putting into that this stuff, like whatever you are using, it'll get it done. If you want to use a particular, you can mention over there, so it will allow to give the name of to the each state. So when a device is probed, default pin control state is requested automatically. So whatever the state we were mentioning over there, it will get it done. Okay. And as you can see here, this UART 1 underscore pins as we are mentioning here, and the name is like the default we are using. Status is also there. Status is basically used for, like, if your device is enabled, then you have to mention OK. So if you don't want to use, just mention over disable. So because there'll be some generic driver also. So if I can show you here some UART 012, we were just checking now. Okay, I'll just go here. Yeah, so see here, so the status is disabled. So whatever the driver you want to use it, so you can just do say OK, that the particular driver you can use it. Okay. Okay, now there'll be, so we were talking about as you can see here, it is disabled here. Here it is OK. It means like the driver we are using this node, this parent node, as there are different child node also. It's there, like this EEPROM at the rate 54, EEPROM at the rate 55. So there are different child nodes also there. This is the parent node of I2C controller. Okay. Now the CPU nodes represent a as I have already explained you, a simple case of addressing. Each CPU is assigned a unique ID, and there is no size associated with the CPU IDs. Memory, which is defined as I've already explained you, that it defines the location and the size of the RAM. I already showed you. Device tree will have the concept of P handle. P handle, you can say pointer in C. Okay, so which help one property to point to another node, just like pointer in C. So we have that P handle property in the Linux device tree also. So this is the property, so which will help you to point. This is Linux P handler. This is the property which will point to the, like, from one node to another node, it will point to that. Okay, so chosen also. Chosen actually basically used in the boot time, where you will have to mention your boot arg property and all. So basically just to pass the information to the system, which is not very hardware descriptive. Okay, so this is basically used for that. Okay, so as I was explaining the interrupt stuff, like you can if your device is capable of handling interrupt, you can use that. And it differs from like address translations, and do not follow the nature structure of the tree, and instead interrupt signals can originate from and terminate anywhere in the machine. So there are different terms in that interrupt controller, interrupt cell, interrupt parent, and interrupt. So interrupt controller controller property is actually it's an empty property. So it's just declaring a node as a device that it receives that interrupt signal. And interrupt cell property, it's a property of that interrupt controller only, and it is basically used for checking like how many cells are in that interrupt specifier for that interrupt controller. Okay, so there is an interrupt parent property also. If you are mentioning is there any parent available over there, and it will it will contain the p handle also to that interrupt controller to which is it is attached, and nodes without any interrupt parent property can inherit the property from their parent node. So whatever the if you don't have the property in that your child node, then it will get it from that parent node. Okay, so as I'm explaining you here. Okay, so as this will not have any interrupt information, so it will get it from your parent. Okay, and finally the interrupt property, which is actually the property of that device node, and which will contain your interrupt specifiers. Okay, so further, like right now it's just like I'm explaining this interrupt stuff, like if you want to use it and all. Further, when we will go to that device driver and we were using the interrupts and all, then probably you will have that clear idea that how it will be connected, so how it will be generate the interrupts and all these things. Okay, and in Linux device tree there is a concept of DMA also, like if you want to use and all. So the DMA, it's like a direct memory access. Suppose okay, so I'll just explain you in a simple layman language that it will just offload the mem copy operations. Suppose you have that user mode driver, you have the character driver, or you have that client driver, you have the low level driver and all. So now you want to write, you want to read and all these things, you are using copy operations and all. So it will just offload that stuff. It will not use that CPUs and all. So it will directly use that memory and all. Okay, so that is the meaning of direct memory access and all. So it depends, like if your data is huge or if your data is less and all, it depends, like if you want to use. But nowadays, like it depends on the you can say requirement, if they want to use the DMA property or not. So if you are sending your data to that by using DMA, then there is a method where you can add your DMA stuff in the Linux device tree. So this is the information which is like what I got from that main source, the device tree source, and I will tell you from where. Okay, so if you want to get more information about the device tree and all, so let me just documentation of device tree kernel. Yeah, so you can get each and every information from here. So suppose if you want to get the information about the DMA, let me just go here. Okay, so it depends like how you want to use. You want to write the DMA controller driver, or if you want to use it as a like there is a client driver present over there, and in that you want to use that DM information, the DMA property and all. So as you can see here, it will give you the information that it generic binding to provide a way for a driver using DMA engine to retrieve the DMA request or channel information that goes from the hardware device to the DMA controller. So there'll be a property of DMA cells, DMA channel, DMA request. The DMA channel is for number of DMA channels supported by the controller. So there'll be a compatible string. There is a rec, there is a interrupts also. So cell is like one property. It must be one. So there'll be a 32 DMA channels. There'll be a 127 DMA request. So if you are using DMA controller, if you are using any client driver and there you want to use the DMA property, so there will be a different property for that. So DMAS, DMA names. So DMAS is used for like list of one or more DMA specifier. So whatever the specifier you want to use, means like if you want to read that DMA, there will be DMA channels also. So the in the like for reading, for writing and all. So for that the DMAS property will be used. And DMA names is basically for the property which will bind, which will define the binding of the DMA client devices. So means like if you want to like there'll be a string also, the string RX, TX, or as you can see here, there'll be example also, a device with one DMA read channel, one DMA write channel, DMA 2, DMA 3 and all. So there'll be a string also which will communicate with your driver, which will just check the strings over there. Okay, so this will have a single read write channel with 3 alternative DMA controllers. So we have different DMA controllers which we can use. Okay, this is the another example. So you can get the information about here. As I'm not use some extra stuff. I have okay. So I'll just check like if there is any DMA information over here. Yeah, so this is DMA cells are there, na? So DMA controller. See, DMAS, different string TX RX is there. See, there will be a different property, TX0 RX0, TX1 RX1. So for different channels, like what you are sending, is it for reading the channel or is it for writing the channel, if you are writing into that memory or not, whatever you using. Or okay, so yeah, so you can get the information like, let me go to the SPI. Okay, so SPI is also there. So I'll go to that SPI bus. Yeah, so this is a serial peripheral interface, that how you can use the fields over here. There is a chip select. So how you can use it, there'll be address cells, there'll be size cells, there'll be interrupt parent and all. So how you can use this stuff and all, you can get each and every information from here. Okay, so you can see I2C, different pin marks is also there. So many information, man. See, parent node, child nodes are there. So there are different nodes are present over here. How you want to use, which port you want to use, as it is using port number 3, you are using its port number 4, whatever the reg property. So this is the reg property is there, compatible string. So this is the string which will check that particular string is present in your driver or not. So these things you can use and all. Now if I can show you that I have the driver now. So this TI my hyphen UART. So I have already built the driver, and I have already transferred my DTB file So to that Peagle Bone Black, I'm this is the compatible string. So I've already done the setup and all, because if I'll do it during this video going on and all now, so that will take time, so that's why the setup is already done, and I have already transferred the driver file also. So let me just insert the UART driver right now. Okay, let me just cat def my UART. It's not there. I'll use my, okay, let me use microcom. Okay, it will also print the logs. My UART. Okay, it's not there. Let me just insert the UART driver. Yeah, it's inserted. Now my UART 0 is at MMIIO. This is the address. Okay, so let me use microcom /dev my UART 0. Okay, so now actually now you can understand, like whatever my driver is. So this is the stuff which I'm using, and this is the driver, how it will be attached. So whenever I'm inserting the module, it is just checking that a string is present, and whatever the property of that whatever the properties in the Linux device tree I want to use, I am using that. So whatever the pins I want to take it, I'm using that. So these numbers and all you can get it from that data sheet. So I will what I will do, like in the next session, like I will explain you like how to use the data sheet also. Some of the guys were getting difficulties to check the addresses also. So probably like I will go through that I will go through that data sheet, and I'll explain you that how to use that. Okay, so I'll show you that how to go through. Okay, so yeah, so in this driver, like whenever I'll just enter, because I have written the driver based on that, like whenever I will enter something, it will just send me okay from that user space. Okay, okay, suppose like I'm just actually I'm just pressing enter. Say I'm just pressing 1, so 1 is pressing, I'm here, and it is returning okay from that user space. 1 2 3 4 5 6 9 1 7, so it is returning me okay. So in this way you can just connect your driver with your Linux device tree. Okay, so this is all about the Linux device tree. So hope you like this video, and I will what I will do in the next session, probably like we are going to introduce the courses in ISKC, SPI driver, and the UART driver also, where we will explain all the driver stuff and how it will be attached to that device tree, because we will write the device tree parallelly, and we will try some good stuff. So thank you so much. Before closing, I just want you guys to like, share, and subscribe to the channel. It is must to grow, and to help others for enhancing and for growing in their IT career. Thank you so much.